This is the On All Cylinders podcast,
powered by Summit Racing.
Your host for today is Summit Racing's Paul Sokolis, with special guest Adam Sondecker from Painless Performance Products.
Here we go.
Hi there, and welcome to another installment of the On All Cylinders podcast. You got me for your host today, Paul Sokolis. And I got to be honest with you, as we were scheduling out our episodes, I thought maybe we should save this one for Halloween because we're going to be talking about a topic that's scary to a lot of folks, even really experienced gearheads, and that is vehicle electrical wiring. So we'll start off with some basics and get into some more advanced theory and practice. And to help us out with all of this, we're enlisting the talents of Adam Sondecker, COO and production manager over at Painless Performance, and he knows an awful lot about how to wire up a vehicle. Adam, thank you so much for taking the time today.
Yeah, my pleasure. Thank you for having me.
So let's tackle this gremlin head on, so to speak. Is it true, have you found out in your experience that even folks that have no qualms about ripping apart an engine or stripping down a body to bare metal kind of get nervous when you talk about electrical wiring and even really basic stuff? Is vehicle wiring that scary of a topic?
Yeah, it's definitely something that people are concerned about. They think it's magic how it happens, and they worry about creating issues down the road, having an unreliable vehicle. And we try to do our best to make it as uncomplicated as possible. And it really is digestible with just a little bit of knowledge and some basic tools.
Well, that makes sense. But before we get to some of the more nuanced aspects of vehicle wiring, let's start basic for the people that are really starting on the ground floor. Can you kind of explain what a vehicle wiring system is, what it does? You know, wires just aren't stretched willy-nilly around the car. Can you kind of give us like a quick overview of what an electrical wiring system is for a vehicle?
Yeah, absolutely. It's going to vary, obviously, dependent from vehicle to vehicle. Older vehicles are going to have a lot less components with electricity in them. Newer vehicles are going to have a lot more, and kind of everywhere in between. But basically anything in your vehicle that is supplied with electricity, whether it be a light, a radio, ignition system, if you start adding electric fuel pumps, water pumps, any of that stuff is going to need wiring harness to interconnect everything and make it work correctly. The main thing that a wiring harness is going to do for you, if done properly, it'll make your vehicle safe and reliable. So when you go to crank it up, it'll turn over, start up, get you down the road, and make an enjoyable experience with your vehicle.
So you kind of touched on this in your initial response, but I just want to make it clear, even if it is kind of an obvious question, you're telling me that a modern vehicle's electrical system is going to be more complex than a vintage vehicle's.
Absolutely. Now, we tend to specialize more in older vehicles, but modern vehicles I've got plenty of experience with, and the complexity is quite incredible. There's different layers of stuff, different layers of modules and computers that all talk to each other and have to be happy. But generally, a lot of our customers, the most complex thing they'll have is maybe like a fuel injection swap, that kind of thing. But for sure, the newer the vehicle, the more complexity and the more challenging it would be to rewire, make a new wiring harness, that kind of thing.
Okay, I just wanted to make that distinction. And for those of you listening, you can exhale now because for most of this interview, we're going to be talking about the earlier cars, maybe from 1980s and earlier, that predated those electronic vehicle controls that added those layers of complexity. But for those earlier vehicles, Adam, and please clarify for me, they're all pretty similar 12-volt systems. And like once you get a basic understanding of what a relay does, what a solenoid does, why fuse amp ratings are important, and what a circuit is, they're all really similar. Is that a fair assumption?
Yeah, that's the basic gist of it. Again, like I said, you get back into 50s and earlier, you start getting some 6-volt stuff. Stuff's not quite as standardized as it was. But basically anything from the mid-60s to about mid-90s is very similar. Of course, you have more and more stuff getting added on as you go down the road, where in the 70s, you might have vacuum actuated things. In the 80s and 90s, like on the air conditioner, your blender doors might be electric, little things like that. So definitely the newer vehicle, the more complexity. But even up into the 90s and early thousands, it's not that complex. It isn't until here recently, the last 10, 15 years, that the complexity's really expanded on these vehicles and the wiring.
Okay, so let's go ahead and dive into some basic troubleshooting then. Say I've got a taillight out on my vehicle. Can you talk about some basic tools and techniques I can use to sniff out the problem?
So the easiest, simplest thing is going to be a test light. They're cheap, readily available. You can get them from Summit, of course. A little bit more expensive, would be a volt-ohm meter. They're extremely helpful in determining, is something grounded? Does it have 12 volts? Is it connected from one end to the other? It'll help you determine what your issues are. You really only need two things for a component to work like a taillight. You got to have power coming to it, and you got to have a proper ground. As long as those two things are there, it'll turn on. So it's just a matter of tracing that circuit and saying, okay, how does it get the power? Making sure everything's connected on the way there. And then is it grounded correctly? And then does that ground make it all the way back to the battery? As long as you have those things, the components will work.
So is that my step one then? I start at the taillight and work myself back to the fuse block or battery?
Honestly, the first thing I would start with, and the thing that we hear with the most on the tech line, is going to be check your grounds. Having stuff properly grounded is the number one issue. It's easy for people to kind of visualize, okay, battery feeds the ignition switch feeds the headlight switch feeds the taillights. It's that grounding where maybe they have a housing that got painted at the body shop and now it's not properly grounded. Maybe they don't have a good ground going from the body that housing grounds into. There's not a good ground from it to the battery. So that's a very important thing, is the grounding, and generally a good place to start. I'd say at least half of the issues we have on our tech line are a result of improper grounds or a bad grounding.
So what's the solution there then? Can you fix that existing ground, or is it possible to add like supplemental grounds?
Well, it's kind of twofold. We have some different kits. One of our series is called the Pro Series kit. It's a universal product, but it's kind of a little more advanced than our bread and butter customizable harnesses. And that actually includes a grounding harness in it. So it'll have integrated into it a harness that will route to the rear section, under the dash, to the front section, to the core support. It's really helpful in like Corvettes, anything with a fiberglass body. It's very important on. We actually started doing that first with our Bronco harness, because a lot of the Broncos, they have remade fiberglass tubs. So we identified that issue a long, long time ago with the Broncos and have started integrating it in. We also have ground strap kits. So what a lot of components will do, they'll ground through the body, but then you need to make sure that body has a good ground to the battery. Typically what I'll do is I'll run my battery cable, my negative, either down to a point on the chassis or a point on the engine. And then from there, you'll want to connect it to all the various components. So if you have it, say, connected to the chassis, you would then want to run a large grounding wire between the chassis and the engine. So that way, your engine, your starter, all your sensors, they'll be grounded properly. And then you'd want to run some smaller ground straps from your chassis to your core support, to your body. If it's a unibody structure, from the subframe to the body. We and many other manufacturers sell different grounding kits. I'd recommend getting a good high quality one. And if you do a proper grounding, you'll really mitigate your issues down the road. And again, that's kind of, you have to complete that path back to the battery, and the ground is going to be on every electronic component, has to make its way back to the battery.
And just for clarification, when you say ground, for those of us that aren't really hip with this stuff, ground is another way to say like the black side of the battery, the negative side of the battery, correct?
Yes, it's the dash, not the plus. So it's the black cable on typical battery cables. And without getting into all how electrons flow and this, that, and the other, basically, like I said, every component is going to have to be grounded one way or the other. And the other thing you'll see a lot of times is if something isn't grounded correctly, it'll find a ground through another component. So if something's grounded to the body, but the body isn't grounded to the chassis and then the battery, it might backfeed and go through a radio, through a different light. It'll find its way to ground if possible. So that's where you'll see a lot of problems. I like to think of it I refer to it as like a grounding node, where you have a central location that your main big, large battery ground goes to. And then from there, you want it to kind of spider web off to all your different components. So you have that one central location, and that really will help reduce feedback or different issues with unwanted, unintended results, where components are turning on that you are not intending to.
And you don't have to be Michael Faraday to realize that's not a good thing. I don't want to put you on the spot here, but is it fair to say that pretty much every post-war American car relies on some sort of ground setup like you've described? And I bring that up only because I know certain vintage British cars rely on a positive ground setup. So I want to, I'll eliminate any confusion for folks out there listening.
Yeah. So it again, things were weird back before the mid 50s. You had, especially on 6 volts, you had stuff that, like you said, is ground positive. It's everything feeds through the ground and it's kind of backwards. You just got to know what you're working with, what that vehicle was originally set for. We actually have a lot of customers that will buy one of those late 40s cars and convert it over to 12 volts. And it's just a matter of kind of working it through in your mind. What was it originally? Finding original documentation, original shop manuals. With the internet, you can find a lot of stuff these days, but try to figure out how it was originally made and then work backwards to the goal of either keeping it that way, ground positive, or switching over to like a 12 volt, more modern standardized system.
You bring up a good point, and it's something that we should really talk about in a little bit more detail for folks that aren't sure exactly what we're talking about. On older vehicles, and we're talking cars and trucks built, let's say, before World War II for a benchmark. These vehicles used a 6-volt system, but as vehicle electronic systems became more complex, as the power needs of those vehicles grew, auto manufacturers began introducing 12-volt systems, and that pretty much carries through to the standard today, where we're using 12-volt vehicle electronics. But for folks that do have those earlier 6-volt cars, is it worth converting to 12 volts? How complex is it? Is the juice worth the squeeze? Is there any advantage or disadvantage? Can you kind of elaborate on that topic a bit?
It really kind of depends on the person. One great thing about the automotive industry and the aftermarket automotive industry is everybody's got a different thing they like. Some guys like original pre-war stuff. Some people want a period correct hot rod. And people like that, I would recommend keep it with the old condenser and the point style ignition. Keep it with the original components as much as possible. Me personally, I'm more into, G machines and pro touring, that kind of thing. I like updated, more modern stuff where you have a cool older vehicle, but it rides and drives and handles like a newer one. So I personally would be more apt to switch it over to 12 volt. It's kind of like, a lot of people are still running around with drum brakes on all 4 corners, but some people switch over and want the disc brakes in the front. They want to add some of those modern touches. So it really depends on your personality and what you like. You can't go wrong either way. There are some nice things about switching over to 12 volt. You get a lot more options with accessories. You get a lot more options with modernizing other parts of the vehicle. Your radio, your ignition, switching over to a modern electronic ignition, or even fuel injection. So there's definitely advantages to switching to 12 volt, but it kind of depends on what you're into. If you want that experience of an older vintage vehicle and that period correct vehicle, stick with the 6 volt. A lot of our harnesses, everything we offer right now is designed for 12 volt. A lot of our customizable harnesses end up in older vehicles doing conversions. We are in the process of developing a 6 volt harness, and really the only difference is the gauge of the wires. So without getting too much into Ohm's law and that kind of thing, if you have less volts, but the same amount of work being done, you need more amperage. More amperage requires a larger gauge wire. That's really all it is. There's not a lot to it. And then the other part would be the ground negative versus ground positive. But if you kind of just in your mind ignore that it's the word ground and you have one side that feeds everything and one side that goes back to the battery, it's very similar.
Okay, so let's keep that thought progression moving forward for a moment. Say I'm restoring a car, and I can take a look at its wiring harness, and I can see maybe it's okay, but not great. Whether it's 6 volt, 12 volt, stock or aftermarket, doesn't really matter. What can I look for in that current vehicle's wiring harness that would clue me in on whether it's a good idea to rip it out and start from scratch, or if there's merit in repairing the existing harness? And I bring that up because I know in talking with like air conditioning folks, more often than not, they'll say, just rip out the old system and start fresh. Does that kind of apply towards old vehicle wiring too? What can you tell us about that?
A lot of that's going to depend on, the condition of the vehicle. We're from Texas, so we tend to have vehicles that have low rust, nicer components. Things haven't rotted away quite as bad. So a lot of people, it's almost a matter of how old it is. The wires will get brittle. You jiggle them, the insulation falls off. You end up with shorts. So the actual harness itself could deteriorate, and that would be one reason why I would definitely recommend looking at doing a rewire. The other thing is who owned it before you and what did they do to it? Is there a bunch of wire nuts or scotch locks on the vehicle? Is stuff a rat's nest under it? We were talking about how you would troubleshoot something. If you have nice, clean, well laid out, even factory wiring, troubleshooting will be easy. Troubleshooting won't be difficult. But if it's a rat's nest and 10 other owners have fixed 10 different things and it's not well organized, you're just going to be chasing problems. And kind of back to your first point where a lot of people don't want to rewire a vehicle because they're intimidated by it. One thing that we like to do is we have very, very extensive installation manuals. Our harnesses come with installation manuals that will range anywhere from 50 to about 160 pages. So it'll cover most of the issues you'd run into. And either on the Summit website or on the Painless website, you can get access to those manuals before you purchase, read through it, and figure out, take a little bit of that fear away, take a little bit of that mystique away from the wiring process. But yeah, definitely a lot of it's just going to depend on how the vehicle was treated before you got it as to whether or not there's necessarily a need. And then the other thing is if you're blowing it apart to paint it, if you're taking every panel apart, you're taking the body off the chassis, you might as well do it while you're in there kind of thing. If everything else is new, there's no sense in putting an original harness back in.
Yeah, that makes sense. But now can you quantify it down to a time commitment? Like, let's just say, an average gearhead that's not afraid to turn a wrench, knows their stuff, and your average domestic passenger sedan or coupe. What kind of time commitment are they looking at to swap out a vehicle's complete wiring harness?
So obviously there's a lot of variables. What are you connecting it to? Are you updating gauges? Maybe you're doing a modern Dakota Digital or Classic Instruments gauge setup. Maybe you're adding air conditioning where there wasn't originally, adding fuel injection. So that'll add to some of the complexity. But I would say your average person on your average vehicle just doing a factory rewire, you're looking at 20 to 30 hours. Part of it's going to depend on how OCD you are about how stuff's run. I tend to take a little bit more time than other people because I like to have things look a certain way. So a little bit of that's going to be dependent on the user and how necessarily neat they are. But I'd say a good estimate would be 20, 30 hours. So that means you and a couple buddies on a weekend, and you can put 30 hours in a weekend, and you can rewire a vehicle for sure.
All right, well, let's change gears or electrons or whatever we want to call them for just a second, because you talked about briefly a topic I wanted to cover. Can you elaborate on things like fuse ratings, amperage, current draw, and that sort of stuff? What kind of things should I be aware of when I'm installing, say, an aftermarket subwoofer amplifier, or a set of off-road fog lights, or a modern set of digital gauges?
Gotcha. So a fuse is basically, it's a safety device. It makes sure if something happens downstream of that fuse, whether it gets grounded, there's an issue in the component, something goes wrong, it breaks. It's meant to break that circuit and keep your car from lighting on fire, which is definitely a goal of a wiring system. And so the main thing with that is you're going to want to have that fuse properly sized for the circuit. So you add up all those components, with a high powered stereo system, it could be a 250 amp fuse, or you could be talking about something like your dome light circuit, 5 amp fuse would be properly sized. So you're going to want to add up all the components and as much as you can figure out what that amp draw is, either through spec sheets, through research, or if you have a clamp-on ammeter, which would be a fairly expensive item for your average guy, you can clamp it on and it'll tell you exactly how many amps it draws. But you want to have that fuse and the wire and everything properly sized. Back to your example of a stereo system. You can put a 250 amp fuse on it, and let's say you had a 500 watt system. That'd be 5,000 watts, pardon me. If you were to put that through an 18 gauge wire, your wire is going to be your fuse. It's going to burn up and light on fire and melt the insulation off far before that fuse will pop. So you want to have everything in that circuit be properly sized in relation to the other components. So like for a wiring harness, one of our chassis harnesses, we'll have a big main fuse, that'll be suitable for your modern alternator. Typically, you'll see 100 or 150 amp. And then that'll feed into your fuse block, which will then distribute it to all the individual circuits. And that's where you'll break it down into the smaller chunks. 20 amps for a headlight, 30 amps for maybe a heater AC system. And it's really just about sizing that circuit to your components. And then, of course, having the proper wire connecting everything.
Well, then I got to ask, is there like a standard best practice for selecting the proper wire gauge for the application?
Yeah, so kind of like everything, the Society of the SAE, Society of Automotive Engineers, they have tables and charts you can find online that'll tell you. So the two keys are the amperage and the distance. So if you have something that draws, and I'm just making up numbers here, if you have something that draws 10 amps and it's going 10 feet, you would need a smaller gauge, which would be a higher numerical number, but a smaller wire than you would for 10 amps going 100 feet. Because that wire itself has a bit of resistance to it. So there's charts, you can find them, go online, go on Google. You can easily find 12 volt gauge recommendations per amperage. It's just a simple chart, figure out how many amps and how long it's going to be, and that'll cover you.
Okay, so we've already talked about quite a few automotive electrical system topics like fuse, amp ratings, 12 volt versus 6 volt, etc. But something we haven't talked about much are relays. And if you look at any vehicle electronic system, you're bound to find several applications for relays. Can you take a bit and explain what a relay is and what are some popular use cases for relays in a vehicle?
So in the simplest terms, all a relay is an electronically controlled switch. It's just a switch that switches either a circuit on or off, or sometimes multiple circuits on or off at the same time. And it's electronically controlled. So a typical use case would be, let's say you have a heavy load that you would want to turn on, say a starter. Ford guys will know exactly what I'm talking about. Your starter solenoid on your fender, that is basically a relay. An electronic signal closes contacts and allows a much larger electrical load to pass through. So it's a small switch controlling a much larger load, and that's what actually handles the load and takes the load is the relay. Another common use that you'll see in a lot of vehicles is going to be to allow a computer to control a device. So if you're doing fuel injection, you're doing that kind of thing, that ECU, that computer, whether you're reusing a factory style system or switching over to one of the great aftermarket systems, that computer doesn't have the ability to handle your 20 amp fuel pump. So it'll actually send a ground signal that will activate the relay, turn on the switch, and then once it's activated, that switch allows the current to pass from your battery to your fuel pump, turn it on your fuel pump. So it's really just a way to let a component that can handle a light load handle a much heavier load.
Well, now that we've talked about some specific components, some specific theories, some specific applications, can you spend some time just speaking in general terms about like good electrical wiring harness care and feeding? Like maybe some installation best practices and stuff like that?
Yeah, absolutely. So a couple of the main things you want to stay away from going to be sharp edges and heat. If you're going to pass it around something, by something, avoid sharp edges as much as possible. Put grommets on it. I'll even take like a piece of vacuum hose and split it and kind of make a little trim ring around a hole or around a panel. So you want to avoid chafing. You want to avoid that wire rubbing up against metal, especially something sharp. Heat also, don't wrap stuff around your headers. Headers make a lot of heat. Turbos make a lot of heat. You want to be cognizant of that. Maybe make heat shields if you need to. It could be as simple as making a little piece of sheet metal to divide that heat away from those components. We carry, and y'all carry some different brands of different wire covering and looming products. We have two different kinds. We call one power braid, one classic braid. And they're just a split loom product. And basically, once you're done installing your wiring, you'll cover everything in these products. And it adds another layer of protection. So if there is that rubbing, if there is that chafing, if there is that heat, you have an exterior layer that kind of takes the brunt of it before you get into the wire and the installation and end up with a short or a problem. Again, there's a lot of products on the market. There's stuff that's specifically for high heat. Spark plug boots would be an example of that. But it's really just keeping it away from heat and keeping it away from sharp edges. That'll make it last a lot longer. And then besides that, it's just being neat. I like to hide stuff where a factory GM may route the wires to your front end right over top of the inner fender. A lot of times I'll hide it between the inner fender and the fender. There's a little channel on the top. So I'll route stuff in there. We like to, in our harnesses, give a little bit of extra length, especially in that front section, to where you can route it in alternate locations to help clean that up, help make it a lot cleaner install. A lot of times you'll use a factory bulkhead and you'll want to reuse that. That's great. We have those options. You have guys with these real expensive pro touring builds, they want to hide every wire. And it's just a kind of a matter of, keeping it away from, like I said, sharp edges and heat are the two main things that are going to kill a wiring harness.
Now, for those folks unfamiliar with vehicle wiring, I mean, you can look at a wiring harness and it just looks like a clump of colorful spaghetti. Do you have any tips for keeping it all sorted? And I mean that both physically and mentally. Like, how do you keep it neat and tidy in your head as you're laying it out to wire it? And once it's in the vehicle, how do you keep your wiring runs neat and organized?
Yeah, so we typically will have stuff grouped with things that are going into similar areas. So, for instance, in the engine section, we'll have all your ignition for your feed for your ignition system, all of your sensors, switches, that kind of thing will be in one section. Your headlights will be in another section. The stuff that goes to your alternator will be in a different section. So we section it out for you. We also, one thing that we and a lot of other harness manufacturers do, and if you are rewiring a vehicle, I'd recommend looking for somebody who does this. We print where everything's going from and going to. So that way, when you're out there and you got a big pile of spaghetti in your hand, you just have to find the writing on it and it'll tell you where it's headed, what it's doing, what it's for. So I recommend do find a harness, whether it's ours or another company that does have that print and that writing on it. It'll make your life a ton easier when you're trying to figure out how to route all that spaghetti to all the different locations and components.
Speaking of the wires themselves, how do they terminate? What's on the end of each wire tip where it connects with the electronic component I'm hooking up?
Yeah, so that's going to depend on the product from us. So we have a couple different lines. We have customizable, which is going to be everything's open-ended. We'll give you a lot of those terminals. We'll give you a lot of those connections. Sometimes with kind of different older stuff, let's say you're redoing an Etzel or a Packard or something a little bit different where the connectors aren't available, you may have to reuse some old ones and do some splicing. So the customizable harnesses, that'll kind of cover everything. We also have what we call our Pro Series. Now that's going to be open-ended, but we supply you with GM-specific connectors and terminals, plenty of them. So you will actually get all that stuff for you to cut things to lane, route how you want it, hide things how you want it, and then apply those factory terminals to it. And then the other option that we have, and that a lot of our other people in the industry carry, are going to be more of a direct fit. So our personal direct fit ones, they have almost all the connections pre-done. If you have let's say you got a 69 Camaro, which is a very popular vehicle, you could go with any of those three options. If you had one that's like nothing stock, you've got a Dakota Digital LED lights, you're doing fuel injection, you shave the firewall, it's got airbags, all the bells and whistles, don't buy the one with all the ends on it. You're just going to cut them off. You're wasting money. You're spending money to get something that you're not going to use. If you have one that like literally all it has is say a Holley Sniper and electric fuel pump in it and everything else is factory, then get that one that'll plug and play. It'll make your life a lot easier. And you're letting us apply those terminals, those connectors here in a factory setting. So it really depends on the build and the goal as to which way you would go. So there are some products that are going to be mostly terminated and some that aren't terminated at all. If you do get one of the ones that isn't terminated, it's not that intimidating. There's a couple of tools that you'll need. You'll need some wire strippers and cutters. You can also, I recommend getting a good set of rollover crimpers. And in our instruction manuals, it'll go over exactly how to do those crimps with all the different, whether it be a ring terminal, a barrel splice, or a rollover crimp. We cover and give you pictures of exactly what's right, what's wrong, and how you should do it.
Now, I was hoping we'd get to this topic because every time we share an article on our social media on this particular subject, it ignites a lot of good conversation and, dare I say it, controversy. So I'm just going to ask you flat out. Do you recommend crimping or soldering when it comes to installing terminals and connectors like this?
We too have posted this on social media before, and boy, does it get a response. My answer is don't solder anything. Everything should be crimped on an automobile. Now, I know there are people that have soldered stuff their entire life and have never had an issue, and I totally understand that. I'm not saying that if you solder a vehicle, it'll just light on fire. I will also say that a good solder joint is better than an improper crimp joint. You know, if you're not going to crimp it right, a proper solder joint will perform better than an improperly crimped joint. But what it really boils down to, without getting too sciencey on you, it's a heat affected zone. So wires are made out of copper. Copper work hardens whenever they turn it into wire. So all the copper in that wire is in a similar state as far as its brittleness, its hardness. Whenever you heat it up to solder it, you're heating up a portion of the wire hot enough to anneal it, to soften the copper. And there's going to be a point where that heat doesn't go down the wire. And there's a heat affected zone where you have hard copper that's been work hardened by the wire making process and softened copper that was softened by the soldering process. And that heat affected zone can lead to cracks and breaks down the road. It's especially important in high vibration stuff. So like you say, a computer, a radio, those are all solder joints. Well, typically they don't vibrate a whole lot. Your TV isn't vibrating on the wall most of the time. And it's that vibration along with the heat affected zone that creates an issue. There's some other stuff you can get into, but you can do some looking online and find there's actually pictures with microscopes of a crimp connection that's done properly, that's cut in half and polished, and you can see all the wires and how they touch each other. And again, not trying to get too technical, but electrons flow over the top of the copper. So as long as you have all that tightly touching in that properly done crimp, you have a good solid connection. Think of it this way. If you take apart even your old harness from a car from the 60s or 70s, nothing is soldered from the factory. Everything is crimped. And that's done for a reason. Modern cars, nothing soldered, everything is crimped, everything's properly crimped. So proper crimp versus proper solder, a crimp has advantages, and that's all we recommend.
Hey man, fair enough here. But let me ask you this, is crimping easy to do? And I ask because I know quite a few people are nervous about soldering. Is that another benefit? Is crimping easier to do?
Absolutely, as long as you have the right tool. Now, if you get real technical, there's exact crimpers for every single different terminal, and you're not going to want to go out as a consumer and buy $5,000 worth of crimpers just to be able to do a wiring install. So look for a good universal one. We have a product that it's actually made in America. We've sourced it from a company that manufactures them in America. They're very high quality. Get you a set of those. There's instructions in our manual that show you how to do it. It's really easy. It's not difficult at all to get a good proper crimp out of a rollover crimp, and it'll look just like the factory.
Yeah, I was actually looking it up as you were talking. If you're out there listening and are interested, just go to summitracing.com and type in the words Painless Crimper into the search box. You'll find it there. Or if you got a notepad and paper handy, the part number is PRF 70900, Papa Romeo Foxtrot 70900. And yeah, it looks like the tool, it can actually work on a couple of different size crimps, right?
It'll have 5 different sizes. Now, one thing that I do like to do, especially on some of the thicker terminals, is start with one of the larger sizes to where it's not actually going to crimp all the way, and kind of get those wings to start folding over, and then put it into a smaller size. And then that's where you'll get that good tight crimp. So I like to do it progressively. It takes a little bit longer, but it generally lends to a better crimp and a better connection. So kind of start with the larger one and work your way down. The one we sell has 5 different spots there where you can crimp. So it'll handle anywhere from a 20 gauge wire all the way up to 10 or 8 gauge.
All right, now let's let that scenario play out. I've got my crimper. I've got my fancy new wiring harness. It's laid out in the concrete in front of my project car. What's my next step? Or I guess I should say, what's my first step? How do I begin retrofitting a wiring harness like this?
First thing is removing the old harness. When you remove the old harness, label things. We include stickers with a lot of our kits that you can actually put onto your harness that labels everything. I just get me a roll of blue masking tape and a Sharpie, and I'll disconnect the wire. I'll put a little tag on it, and I'll write radio feed. I'll disconnect something, and I'll write blower resistor, whatever that component is. So label everything as it's coming out so you have a good reference of where things need to go when you put stuff back in. From there, start with the fuse block. Almost all the wires are going to go to the fuse block. Get that mounted, and then start routing things in large chunks. From the fuse block, typically, you're going to have a dash section that'll go out under the dash. You'll then have a section that goes out under the hood, and you'll then have a section that'll go back towards the tail section. So get those big sections routed off, kind of headed in the right direction. And then, the old saying, how do you eat an elephant? One bite at a time. Just start with one of those sections, start with one wire, figure out where it goes. Start with a couple wires, figure out where they go, and really break it down into digestible chunks. You're not going to do it all at once. Another thing that's very helpful to do out ahead of time, mount all the stuff that the electricity needs to go to. Get your ignition box mounted. Get your computer for your ECU mounted. Get all those different things, the controller for your gauges, whatever they might be. Get them all in a place, get them mounted, and then that'll give you a target to head to. You know what I mean? It'll give you an idea of, okay, I got to get from point A to point B. If you don't know where point B is, it's hard to get a wire to it.
Yeah, a couple little helpful tips to make that installation job go a bit easier. We're about out of time, but there is a topic I did want to cover in a bit more detail than we have already. EFI, or electronic fuel injection retrofit kits, seem to be all the rage with those hot rodder kids nowadays. From an electronic standpoint, is there any specific fuel injection topic you'd like to cover?
So fuel injection is a popular upgrade to any car, especially people that want a more modern vehicle. Let's say we're in Texas, we're pretty close to sea level, and I want to drive up to Colorado. I don't want to have to adjust my carburetor and my timing as I go up the mountain. So fuel injection is a very popular upgrade. There's a lot of different ways you can go with it. There's a lot of the throttle body injection systems like your Holley Sniper. Those are great. We offer actually engine swap harnesses where you'll take your Gen 3, Gen 4 LS style motor, swap it in, and then use a factory computer, and it's all plug and play. There's people that want to put turbos and a bunch of nitrous and a giant cam, and they don't want to mess with tuning a factory computer, and they're going to go with more of a standalone system. So one thing that's important with those is between ours or any of the other systems, again, is grounding. So with those, you'll have a chassis ground and an engine ground. You want to make sure, especially on that engine ground, pick a bolt on the back of the cylinder head and route everything to one node, one spot. It's separate. You don't want to route that stuff to your battery because it needs good, clean. That's how your signals, that's how everything's communicating to that computer. Systems are of varying complexity. I've installed standalone, Motec and some of those higher end systems that you'll spend 100 hours wiring. It's very, very complicated. You have to make something custom. The harnesses that we offer are relatively plug and play. There's about 6 connections that you have to hook up between your chassis and your fuel injection harness. Makes for a real easy install, especially if you're doing just a mild cam and intake, and you're running the mill swap. It takes a lot of that complexity out of the engine system and the fuel injection. But yeah, one thing that's very important when you're looking into that fuel injection is having good grounds and separating those chassis grounds from your signal grounds in your computer and keeping your computer happy.
That is good insight. And again, it all goes back to grounds. So with that, I'm going to swing the microphone around to you and ask you, what can you say to folks out there listening that are nervous or apprehensive about doing any vehicle wiring? Try to calm some nerves out there.
There's not as much mystery to it as you think. If you buy something from a good, reputable manufacturer, they'll have a tech line. They'll have somebody to help you out. A lot of times before I buy something, I'll go in and I'll download a manual. I'll look and I'll say, okay, how hard is it to do one of these Holley Terminator systems? You buy that system, read the manual, understand what you're doing before you get started. And then if you get something from a good, reputable company, when you run into issues, whether it's with our harness, whether it's with one of the other great manufacturers out there, you call the tech line and you'll get somebody knowledgeable that can help walk you through it. So just know that It's not that complicated, but if you do hit something, you do hit a snag, as long as you buy it from somebody that stands behind their product, they'll help you work through it. They'll help you get it installed and get it working correctly. And that's the big key, is the support when you do hit those issues, whether it's from us, from y'all, or any of the other great companies in our industry.
Yeah, and you know what? That holds true whether we're talking wiring harnesses or cylinder heads. And that is a great note to end on. Hopefully you've learned something about the electrons flowing through your vehicle's wiring harness. Or maybe even better, you've got the confidence now to grab a set of wire crimpers and wire strippers and start installing or modifying your own vehicle's wiring. Either way, we just hope you had fun over the last 30-40 minutes. We've been talking with Adam Sondecker from Painless Performance all about vehicle electronics and wiring. Adam, thank you once again for lending your expertise with us today.
Yeah, it was my pleasure. I enjoyed it. Thanks for having me.
This has been the On All Cylinders podcast.
Powered by Summit Racing.
Check out new episodes coming soon at OnAllCylinders.com.
OnAllCylinders.com.
Thanks for listening.
See you next time.